Hey, Katie, I'm going to start doing the first couple of problems again. The first one was about rowing with the river versus rowing against the river. And you have two things to contemplate. Your speed in a still river where there's no current, and the velocity of the current. You're either going to have your speed in still water, that's this, plus the current, or you're going to have your speed in still water minus the current. You're either going upstream or downstream. I'm going to do these in pieces, and part of it is because I'm about to eat dinner, and part of it is because I can only do these in 15-minute intervals. So on the one case, a lot of the equations that we're dealing with here, the driving equation is distance equals velocity times time, which should make total sense to you. That is, if I drive 60 miles an hour for 2 hours, I've driven 120 miles. So it's not a fancy equation by any means. What we're told in the case where when we're rowing with the current is that we got to add those two equations together, add those two velocities together, and that times 3 hours equals 30 kilometers or meters or whatever it is. I can't remember. I'm not looking at the details of the problem. In the case where we are going against the current, we have that situation where it's the velocity of the boat in still water minus the velocity of the current. That's how fast we're able to go. And in that case, it takes us 5 hours to go those 30 meters or whatever, or, 3, whatever the details are. I can't remember. 3 minutes, 3 seconds, whatever it is. Doesn't matter. This is a system of equations, and it's an easy system of equations to solve. If I divide by 3 in the first equation, we're going to get and if I divide by 3 in the by 5 in the second equation, we're going to get that. Easy equation to solve because I have V sub s, looks like a radical, but sorry about that, it's a V, and plus C and a minus C. When I add those two left sides together, we're going to get a 2 times V sub s equals 16, which says V sub s equals 8. And when I plug that equation up here, I can see I need V sub s plus V sub c to equal 10. And if V sub s equals 8, then V sub c has to equal 2. And that was the question. The question was, what does what's the velocity of the current? So that's that question. I'm going to do at least one more, and then I might take a break to eat dinner, and then I'll send you more stuff. All right, Katie. So I'm going to move on to the next problem that we had. We solved it in two different ways. One way was nice and easy, but it doesn't always apply as an easy solution. So I'm not sure you shouldn't just apply the same approach that I did to the first one to the second one. The second one said, Second one said that if, well, that was the third one. The second one was, my crud. Let me look, Katie, for a second. The second one was, well, one of the next ones was easy because it said you're rowing across the river at 2 meters per second. Two meters per second. 2 meters per second. The current is 3 meters per second. This is going perpendicular to this, and so in vector analysis, this 3 meters per second is doing nothing to affect this velocity or speed of 2 meters per second going across the river. The river was 100 meters wide. So without much thought, we can say that the time it's going to take to get across the river is 50 meters, is 50 seconds. And in that, I think the question there was, how far downriver will she be? And she's going to be 50, it's going to take her 50 seconds to get across the river, and every second she's going 3 meters to the right. So in 50 seconds she's going 50 times 3 meters to the right equals 150 meters. That's our answer to that question. Maybe I'm going to try to do one more, Katie, before we wrap up this first blast. And then I'll send you some more stuff in a little bit. Let me find these terrible questions. Oy, oy, oy. Oh yeah, we had a harder one which said, I'm not writing down the numbers of these problems, but we had a harder one that said, if I were to walk without the escalator from the gate that I disembarked on at the airport, without the escalator thing, it would take me 50 seconds. to get to the baggage claim. If I only walked on the, if I only went based on the escalator, but didn't walk, it would take me 75 seconds. Now I'm going to tend to solve this problem the same way I solved the first problem. And that's in a distance equals rate times time kind of way. And that's going to say that it took me 50 seconds at some rate walking to cover some distance. Okay? And based on the second scenario of the rate of the escalator thing, it would take me 75 seconds. That's my time. At the rate of the escalator to cover the same distance. In both cases, we're going this distance there. So then I've got a system of equations, and I can say that 50 RW, R sub W, this should be sub, R sub W equals D. Wait. Well, let me do this. Let me say 50 R sub W equals D, and 75 R sub E equals D. So those things must be equal to each other. So 50 R sub W must equal 75 R sub E. Now I have this equation, and I'm really trying to stick all this stuff in some way into this equation, kind of. If both things are working together, then my rate is going to be R sub E plus R sub W. That's the escalator's pace plus my walking pace times time is going to equal that same D. But these two guys, again, I could do this in different ways, but the way I think I'm going to do it is I'm going to say I can solve this first equation for R sub W, which means I want to divide by 50, and I can solve this equation by dividing by 75 to get R sub E, and I'm going to get R sub W equals D over 50, and R sub E equals D divided by 75. And putting those two guys together, I'm going to get R sub W, this guy, I'm going to call it D over 50, plus R sub E, which I'm going to call D over 75.